Hi guys, Mrs. Dono coming back to you. Today we're going to be doing DNA extraction from a strawberry. This usually is one of the most popular labs that you get a chance to do in high school biology. Unfortunately, thanks to the coronavirus, you guys are stuck at home and I'm stuck at home, so I figured I would do a little recording of myself doing the experiment so you could see how it works firsthand. And then if it's something you think you want to try at home, I would be more than happy. In fact, I'm going to drop a list of ingredients that you will need in order to complete this lab at home. Okay, if you're not interested in completing the lab, not a big deal. Just go ahead and watch this video. I am going to be working with my faithful assistant today. This is Emily. We'll call her lab assistant Emily.
Hi.
She is actually going to be performing the lab while I give her some instructions so you guys can take a look at it. All right, so we have our stuff right here on the counter. So we have our equipment that we need set up right here. You can see we have a strawberry, we have a plastic bag, we have a test tube rack, and some, even though it looks radioactive, it's just some detergent back there, okay? And as we go through the lab, I'm gonna talk to you about exactly what's happening. Are you ready, lab assistant?
Yes.
Okay, let's go ahead and begin. So go ahead and take the leaves off of that strawberry and just set them on the counter.
Trying to pull out the thing.
Okay, perfect. Now she's going to put this strawberry in this plastic bag. What she's going to do is she is going to smash this strawberry up. Make sure you get all the air out of the bag and close the bag. And she is going to begin mechanically breaking down that strawberry. Okay, you guys probably remember from way back when, a strawberry is a type of plant. So we're gonna have to, go ahead. Yep, we're gonna have to mash up that strawberry in order to get inside of those cells. Okay, you guys will probably remember that DNA, which is what we're trying to extract from this strawberry, is going to be found where? Oh, that's right, inside of the nucleus of our strawberry cells. Okay, so in order to access that, first we have to mechanically break down this strawberry. So I'm going to give Emily just a few more seconds to keep mashing that strawberry. She wants it to look like a good strawberry puree. All right, I would say that looks pretty good. Okay, so now she's going to take her detergent solution and she's going to empty all of it into this bag. Nice job. She's going to close the bag up and she is going to give this guy another mix. A good mix for about a minute. So if you decide to do this experiment at home, make sure that you are doing the same thing. Make sure all your pieces are broken down, Ems. Alright, so real quick, I just want to talk to you guys about what's happening. So if you guys remember, our cells have a special membrane around them. Okay, does anybody remember what that special membrane is? That's right, a phospholipid membrane. Okay, and if we remember, we have those phospholipid heads and tails. Okay, so what's in this green concoction that Emily poured into the bag is actually a detergent. It's a soap. And what it does is it's actually breaking down that phospholipid membrane. It's busting those heads and tails apart and allowing that DNA to actually flow out, so that here in a minute we're going to be able to extract it. And then we're going to clump it all together so that we can actually see it. Okay, ma'am, I would say that looks good. So now here's the trickiest part of this lab. Pouring it in to this. Let's get a better shot there.
To the...
Okay, so now she's gonna empty her mixture carefully. I'm gonna hold on to this for you. I want this open a little more.
Just don't... Yes.
Yep. Oh shoot, we need another test tube. Ah, I was afraid that was gonna happen.
Test tube, test tube.
That one's a little big. We're gonna let this guy sit for just another minute or two, and then we're actually going to extract the DNA. Okay, so we'll come back in just a second. All right, guys. Looks like we've got a good amount of liquid extracted from our original solution, from our strawberry and our detergent mix. Okay, again, like I was saying, that detergent just serves as a way to break down that phospholipid bilayer, essentially releasing that DNA so that we can take a look at it. Okay, Assistant Emily, will you go ahead and hold this test tube for me?
Yes, ma'am.
I'm going to throw this away.
Okay. Smells
All
really
right,
good.
so the next thing that we need to use is ethyl alcohol. Okay, so this ethyl alcohol has been chilled to very cold, but because it's ethyl alcohol, it will not freeze, at least not in a traditional freezer, because it has a much lower freezing point than most other things. Okay, so it's very, very cold. Yes, this is the same ethyl alcohol that is used to make hand sanitizer. So if worse comes to worse, yes, the Dono family might be making hand sanitizer out of ethyl alcohol. Okay, so Emily, what she's going to do is she is going to take this ethyl alcohol and she is going to slowly pipette it into the strawberry solution. And she's going to hold it really close to the camera. You're going to start to see some white string, almost looks like spider webs, and some bubbles forming. This alcohol actually causes all the DNA that's in that strawberry mixture to stick together and do what we call precipitate. So that means it sticks together and we're actually able to see the DNA threads with our bare eyes. Naked eyes, not bare eyes. All right, Miss Emily.
Okay.
Now slowly take this pipette and squeeze it in there. Tip your thing.
Like this?
Mm-hmm.
I don't want to do too much at a time.
You're okay. All right, Emily, hold it up really close to the camera so they can start to see. Can you see the white bubbles and the strings? That's strawberry DNA. So Emily, go ahead and keep holding it there. I'm gonna go ahead and add a little more alcohol.
And it's staying right above the strawberry.
Yep, you can see it. It's literally floating right on top of the strawberry mixture. It's really cool. Okay, I'm gonna put just a little bit more in there. So see right there, that right there, guys, that is strawberry DNA. And watch this, I can even pick it up with my pipette. And see how it almost looks like a booger?
Ew.
That is strawberry DNA. Okay, now if we had an electron scanning microscope, which I don't, but if I did have one of those, it would look just like this.
The DNA test turns out I'm 100% that
Strawberry. well, that's enough of that. So let's go ahead and shoot back on over to Emily and take a look at that DNA one more time. All right, thanks, Emily, for your help. We have 2 sets of strawberry DNA here. You can see here's one.
The DNA is floating at the top.
You can see the DNA floating at the very top. Emily has a smaller test tube here, and you can see the bubbles floating around in there. That's strawberry DNA. So real quick, let's just do a real quick review. Remember, DNA is a double helix shape, and it has certain bases, nitrogen bases, that pair with each other. Let's real quick review them. Adenine pairs with thymine, and guanine pairs with cytosine. There is a sugar phosphate backbone, and that is what gives this DNA that that double helix twisted spiral staircase ladder that we know that DNA looks like. All right, guys.
And now the DNA is moving up.
Oh, Emily wants to show you one more thing. The DNA is starting to float on the very top.
It's staying on the sides.
And we can even add a little more to it.
Make it nice. See, it made a squiggling motion as you can kind of see that squiggle. There it is. It's hard to focus.
That's okay. All right, put your tube in here. Or you can put it in the test tube rack.
Goodbye.
Thanks for your help, Emily.
Bye.
All right, guys, I'll catch you later. Thanks for watching this. Outtakes from the DNA.
So, it's like a booger. I got it out. Do you see that? Stop focusing on my face.
Yeah, it's like a booger.
See it.
And if any of you guys out there are fans of crime shows like Criminal Intent or CSI or anything like that, guys, this is a similar process that detectives or forensic technologists actually use in order to identify criminals from their DNA left behind. Generally, a criminal might leave behind some skin cells or maybe a hair, and detectives can collect that evidence, send it to a forensic lab, and then forensic technologists can do a similar process where they can actually break down the cells, extract the DNA, and then they can use some type of gel electrophoresis or some type of technology in order to match that DNA to somebody who might already be in their database or somebody who they might have as a suspect.
Yeah.
Did you want to say something else, Assistant Emily?
Moral of the story, don't commit crimes.
Thank you, Emily. All right, guys, thanks for watching. If you're going to try this experiment at home, let me know. Just be careful. The one thing you might have a hard time finding is the ethyl alcohol. It can be replaced with isopropyl alcohol, but unfortunately right now with our whole social distancing coronavirus scare, that might be a little hard to come across. But if you really want to do this experiment at home, let me know and I can get you a small vial of ethyl alcohol.